Hello, and welcome to another Algebra 1 lesson. This is lesson 10.4, Find Inverses. Here's some warm-up problems. Determine whether L2 is a reflection in the line y equals x of L1. So we have line 2 and line 1. Here's L1 and L2 in the first problem. The line y equals x is this dashed line that goes through 1, 1, 2, 2, 3, 3, 4, 4. Are these reflections? That's what we're asking. So what you can do to tell if a line is a reflection or if something is a reflection across another line is draw a line perpendicular to the line of reflection. Whatever distance you go to get to that line of reflection, you need to go exactly that far on the other side. And any point on the line would have to be on both of the lines, the line and its reflection. So these two are a reflection. In other words, if you were to fold this on this dashed line, would these two lines match up? Kind of like a butterfly. Yes, these two are reflections of each other. What about number 2? If you were to fold it in half on this line, do the two sides match? No, they do not. Like this point, if we go perpendicular to the line and go that far on the other side, there would need to be a point right there, and there is not. So this one's a yes. And this one's a no. Ooh, some review problems. Factor. Factor the polynomial x squared minus 9. This is the difference of two perfect squares. Factors into a sum and difference pattern, x plus something times x minus something. What are the two numbers that multiply to be -9 and add to be a 0? 3 and -3. So this is one of those patterns we're supposed to memorize, that whenever we have the difference of two perfect squares, a squared minus b squared, it factors into a plus b, a minus b. All right, factor number 2. Y squared is a perfect square, and the number 1 is a perfect square. So the square root of y squared is y. Square root of 1 is 1. We get y plus 1 times y minus 1. Follows the pattern. Number 3. Perfect square, perfect square. So this is the difference of two perfect squares. Square root of 9x squared is 3x. So we get 3x plus square root of 4 is 2. 3x plus 2 times 3x minus 2. And number 4. This one is not the difference of two perfect squares, but it's still going to be a double bubble. What are two numbers that add to be -10 and multiply to be positive 25? -5 and -5. So this is actually a perfect square trinomial. Like when we learned how to complete the square, and we would get things that factored into a binomial squared, it's kind of like that. So x minus 5 times x minus 5, we write it as x minus 5 squared. Okay, Factoring is very important. We use it a lot, especially solving quadratic equations. Okay, back to inverse functions and inverse relations. An inverse relation is when a relation contains a point AB, then the inverse relation has to contain BA. So if we find the inverse of this set of points, -4, 7, -2, 4, 0, 1, 2, -2, and 4, -5, we just switch the coordinates. So -4, 7 becomes 7, -4, and so on. You just switch the x's and y's, and you get an inverse. Now what about a table? They give us an input-output table or an XY table. The inputs become the outputs become the inputs. So the -1 through 4 that were the inputs become the outputs, and the 5 through 30 that were the outputs become the inputs. And we have an inverse relation. Let's give it a try. Find the inverse of the relation. Write it down. -3, -4. In the inverse, what's that going to become? -4, 3. And the next one? 0, -2. Keep going. Write down the inverse. And number 2, the input numbers, -2 through 2, become our output numbers. And the output numbers become our input numbers. And there's our inverse relations. Notice these aren't functions yet, they're just inverse relations. Finding inverses of functions algebraically. Step 1, set y equal to f of x. Step 2, switch x and y. Step 3, solve the equation for y. Find the inverse of f of x equals 4x minus 9. So switch out the f of x for a y. So set y equal to f of x, so we just replaced it. Now to find the inverse, x and y switch places. And solve for y. Okay, to get rid of -9, what do? Add 9. So we now have an x plus 9 on the left side. We are solving for y, so we need to get the y by itself. Y is being multiplied by 4. How do we undo multiplication? Division. So divide both sides by 4, and we get y equals x plus 9 over 4, or we can write it as x over 4 plus 9 over 4. Sorry, I had it paused for a moment. Not sure where I left off. Example 4, We had y equals x squared. Switch the x and y, solve for y. We get y equals the square root of x. And notice these two are reflections of each other. Example 5. I might be repeating myself, sorry. Horizontal line test. The inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So vertical line test, test for functions. Horizontal line test, test for one-to-one function to see if we have inverses. So when we graph a square root graph, like square root of x plus 2, it is a square root graph. It looks kind of like this, but the plus 2 moves it 2 units to the left. So that's what this graph will look like. We have to see if it passes the horizontal line test. So here's a horizontal line. It only touches this graph, we're ignoring the x and y axis, in one point at a time. So that means it passes. It passes the horizontal line test, so it does have a function. So is the inverse of f a function? Yes. Yes, it is, because a horizontal line only touches it in one spot at a time. So we say yes, and then we go and find the inverse. So replacing f of x with y, we have y equals square root of x plus 2. To find the inverse, we rewrite it with x and y in opposite places. They switch places. So we get x equals square root of y plus 2. And solve for y. The y plus 2 is all inside the square root, so square both sides. That undoes the radical. So we get x squared equals y plus 2. Finish solving for y. Undo plus 2. And then we have our final answer, x squared minus 2. And that's example 5. Finding the inverse, switch x and y, solve for y. Explain the steps you would take to find the inverse of f of x equals 3x minus 4. Then find the inverse. So what did we just do? First thing, we replace f of x with a y. Then what? What was the big step? The most important step to finding an inverse, do you remember? Okay, hopefully you remember. Find the inverse on your mark and set, go. Check your answer with mine. I only showed some of my work this time. So I switched my x and y. So that's the big step. That's the explanation. Switch x and y, solve for y. So I added 4 to both sides and wrote down my answer. Then I divided both sides by 3 and wrote down my answer. And there we go. And here's what you need for Big Ideas Assignment 10.4. Thanks for watching. Work hard on your assignment. Have a great day.